Everybody. So this is the video where we're going to do the charting stars model directions, and I will also show you an example for this. So now that you've learned all about stars, it's time to try charting your own through creation of a model. Your model can be made using any sort of technology, or you can even craft it with materials at home. So this could be a Google drawing, it could be a PowerPoint, a diorama, a Prezi, a drawing, or any other method, as long as it includes the required elements. So feel free to be so creative with this. If you have materials to create a diorama, great. If you want to use the internet and technology, fantastic. Anything you want to do. Your model must include, though, in any format, the sun, the earth, and at least 5 stars from the following link. And I will go to that link and show you that in a second after this part. So not only do you need to include the stars, the 5 of them, you must create an approximate scale to place them accurately in your model. So if you're creating a physical diorama or a drawing, then you have to draw the stars and the sun and the earth to scale. So as we've learned, the sun would probably be the biggest model on there because the sun is pretty big. And then the earth would probably be the next one, and then we're depending on the size of the stars. If you find a star that's bigger than the earth, then you would draw that to scale. And let's say you're doing a PowerPoint or a Prezi, then you can include the numbers to the scales, if that makes sense. So you can include just the physical numbers of like how big they are, or their apparent magnitude or their absolute magnitude, because it'd be kind of harder to draw those on a PowerPoint or a Prezi. But if you can do that, great. If not, just at least include the numbers for the approximate scale. So next, you will make an argument to complete your 2 statements below in your science notebook. So this will be done after you finish your complete charting stars model activity. So you must include your claim and provide evidence based on your model and learning throughout this lesson. So in this whole lesson and all that research you do in this model activity on that website linked above, that all can be included in your explanation and answers for this 2 questions below. And don't forget to include the new vocabulary we learned in the lesson earlier. So those should also be included in your science notebooks. So the 2 questions we have are: the star that would appear the brightest from Earth would be blank. And so you can use that website to find something. You can look at others and also include those vocabulary words like apparent brightness, absolute, or apparent magnitude, absolute magnitude. You can say how those compare to the Earth and why that's the brightest star. And then the star that would appear the least bright from Earth would be blank. So with this, you can actually research which star is exactly the brightest and which one's exactly the least bright. Or from your 5, you can choose out of those 5 which would appear the brightest from Earth and which would appear the least bright. And then we attach this rubric below to use when planning and developing your model and arguments, just to make sure you guys know what we expect from you from this. So we come back up here. So if we click this site, it'll take us to this site. So stellar brightness, the brightest stars as seen from Earth. So this lists a bunch of stars from it. And so as we go through, so the common name, so these are the names people have given to them. Some of them might sound familiar. So the sun, obviously, is the first one, the brightest. Then there's Sirius, Canopus, Vega, Rigel, there's Altair, Pollux. There's so many. You can feel free to choose any 5 or more if you'd like, but at least 5. And then it has a scientific name here. You can include this, but it's not necessary. So you can just include the common name if you like. This has the distance, so that's one of our vocabulary words, so you should include this. So the light in light years, though. So for example, Sirius is 8.6 light years. Then it has the apparent magnitude. So Vega, for example, if we go here, it's 0.03 magnitude, apparent magnitude. Then the absolute magnitude for that same star would be 0.6. So it is different, as you see. So it went all the way from 0.03 to 0.6. And then you do not need to include this spectral type, because that's kind of not what we're focusing on. Then if you scroll below, it explains a little bit about the magnitude numbers. So it says the magnitude numbers, they're ranked the stars so he can see in terms of their brightness. So 1 is representing the brightest, and then 6 represents the faintest. So if we come back, so the apparent magnitude, as we see, some of these first ones are negative, and that makes it seem like, so that means if 1 was brightest, that means they're even super bright. They're actually brighter if we look at them. but their absolute magnitude, which is their actual brightness, would actually be 1.4 or 4.8, so it is slightly different. So that's why we learned that apparent and absolute magnitudes are different, because one's as we see from Earth, so this is how bright they appear from Earth, this list, and this one's how bright they appear, or how they actually are. So as you go through creating your stars, you'll pick 5 or more from this list, and you'll write down all this information, excluding the spectral type, and you don't need the scientific name, but you can include it. You'll include that in your presentation. So an example presentation, so I decided to create a Prezi. So like I said, this was very easy. I just typed in prezi.com and I clicked start new and simple, and it just came with this. Like I said, you can do Google Slides, you can do, or any other type of PowerPoint, you can create a physical diorama, all that stuff. And so I put these in order of how they appeared on there. So I started with the Earth and the Sun, because it starts from the Earth and it goes out. So let's say I click on as you can see, hold on, I'll go back real quick. As you can see, I did not draw these to scale, because obviously all these stars are not the same size and shape. So what I did is so in Sirius, so we'll go to the first star I did. So I included the distance from Earth, 8.6 light years, the apparent magnitude, negative 1.46, and the absolute magnitude is 1.4. And then I decided to include a little picture. I found from Google Images of the star. You don't have to do this, but I thought it'd be fun to include. And so, like I said, you can be as creative. You can like really decorate and play with the colors, transitions, the style, all that. I just did a very simple one. But yeah, so I got all this information from this website. So I just followed this line and I went down and I put it in here and organized it. And so yeah, so you would go through, you would do this for all of those stars in there. So I did 5, like I said, you can do more or less. So basically that is it. I'm going back to directions. So I included 5 stars. I had the sun and the earth as well. And then I included the approximate scale and important numbers. And like I said, feel free to be super creative. Mine was pretty basic. Like it just has simple colors, simple images. But like I said, feel free to be as creative as you like. So that would be all for this directions and example. If you need any more help, you feel free to ask questions about it. And then if we go back to our Google Slides classroom, so on slide 21, you're going to submit on the star. So you click the star and it'll take you to our Google Classroom and you can submit your model there. And that'll be all. Thank you guys.